Hello. We are going to talk about valence electrons today, and we're going to then use that information to make what's called an electron dot diagram, or also called a Lewis dot structure. Lewis was a guy. So basically, it's named after an old white guy. Okay, Lewis dot structure. That I don't really care about too much. What I do care about is that you can make an electron dot diagram. So, in order for us to talk about valence electrons, we first need to take a look at some atoms. And when we look at those atoms, we're going to try and figure out how many electrons they have, right? So let's go look at the periodic table. Okay, so let's take a look at hydrogen. So hydrogen right here has an atomic number of 1. This means that hydrogen has 1 proton. Okay, and since the atomic mass is 1.008, which is basically 1, it has no neutrons. So the nucleus is just a single proton, right? You remember protons and neutrons are in the nucleus. Okay, and also, when we look at the periodic table, we assume that all of these elements that are organized here, we assume that they are all electrically neutral, which means that they should have the same number of protons as they do electrons, right? Because protons are positive and electrons are negative. So if we have a 1 for our atomic number, there's 1 proton in the nucleus and there should be 1 electron around the outside. So let's go back to our thing here and let's draw hydrogen. Okay. So hydrogen is 1. Okay. Right. I'm sorry. There's also a 1 down here. My apologies. Okay. So hydrogen has 1 proton. So let's make a nucleus and we'll put 1 proton, 1p plus inside. There's also a neutron in there, but that doesn't matter too much for this particular example. And all right. So we also know that there's going to be an energy shell out here. And inside of that, there's going to be a single electron. Wow. We did it. Amazing. Okay. That is the Bohr diagram, right? Or the Bohr model, right? For hydrogen, right? Okay. Now let's go back to our periodic table and let's do lithium. Okay. We're going to use the first column for an example just because it's right there and it's easy. Okay. So lithium. Lithium has a mass of almost 7. Lithium has an atomic number of 3, which means there's 3 protons. That also means there should be 3 electrons, right? Okay. So if you have a mass of, we'll round it up to 7, that means there's 4 neutrons in the nucleus. So I'm going to actually draw the neutrons for this one just because I want you to remember how to do this. Okay. So let's go ahead and do lithium. Do it right over here. Okay. Lithium. Okay. So lithium, we're going to draw the nucleus, and there's going to be 3 protons, and there's going to be 4 neutrons. Okay, great. Now let's draw an energy shell, and let's go back and look. It says there's 3, so there should be 3 electrons, right? So if we need to put 3 electrons on this thing, we're going to put 1 here. We're going to put 1 here. Now, if you remember from before break, we were actually talking about how the first energy shell can only hold 2 electrons, right? Then there's another energy shell, this one. And this guy can hold 8 electrons. So let me use a different color. We use pink. And we're just going to make openings. 2, 1, 2, 3, 4, 5, 6, 7, 8. So pretend that those pink circles are all places that electrons could go. There could be electrons there, right? Well, in the case of lithium, only one of those is filled, right? Only one of those is filled by an electron. Okay, so that's our Bohr model for lithium. Okay, now what we need to remember is what the heck is this valence electron thing? So, valence electrons are the electrons that are in the outermost energy level. Okay, so basically, you're looking for the energy shell that's not filled, or well, the outermost one, because sometimes they are filled, and you're just going to count. So, how many valence electrons are there in hydrogen? Well, there's 1. How many valence electrons are there in lithium? Well, there's 1. Okay, so let's head back to the periodic table, and we're going to try again with sodium to make the Bohr model. Now, eventually, I'm going to show you a trick, kind of like cheat codes that are going to help you do this without taking such a long time. Okay, so sodium. Sodium has 11 protons. Again, there's 23 atomic mass, which means if there's 11 protons, there's going to be 12 neutrons. So that's 11 protons, 12 neutrons in the nucleus. There's also going to be 11 electrons, right? Because sodium's supposed to be electronically or electrically, sorry, neutral, right? So there should be 11 electrons. Okay, so let's do sodium really quick. Okay, sodium. In the nucleus, there are, I said 11 protons and I said 12 neutrons. Okay, great. Energy shell number 1. I'm going to actually have to move this. Sorry. Energy shell number 2. Energy shell number 3. Okay, let me get my pink. out again, and we'll look at this. There could be 1, 2 electrons in the first level, and then there could be 1, 2, 3, 4, 5, 6, 7, 8 in the second level, and then there could be. Do we need the third level? Yeah, there could be 1, 2, 3, 4, 5, 6, 7, 8 in the third level. Okay. I know that looks a little complicated, but I'm basically just trying to show you that those are the possible places that electrons could be, right? And like we talked about before break, this isn't actually what happens with the electrons. They're not like sitting on these nice, neat, even rings and spinning evenly and consistently, like around, like their planets orbiting a sun. That's not what happens, but it's good enough for us. Okay. So remember, we've got 11 electrons, and we need to fill these shells. And we're going to start with the innermost shell, right? Think about it like, um, where are people going to park when they're going to a place closest to the place they want to be, right? So if the nucleus is where you want to be, then you're going to fill your closest spots first. So there's 2, and then we're going to do 3, and you're going to watch how I do this, right? Because electrons, when they fill shells, they want to be as far away from each other as possible, right? So we'll go top, we'll go bottom. Okay, that's 4. Then we're going to go. You can do either left or right first. Doesn't really matter. It's kind of like north, south, east, west, or well, sorry, north, south, east, west. But I went west first. So 1, 2, 3, 4, right? And then you can just kind of double up. 5, 6, 7, 8. Okay, so we filled the entire shell. So we have 8 there plus 2 here makes 10. So we have room for 1 more electron. Okay, and so if we pop that electron in the outermost shell here, there we go. There's our 1 valence electron again. So you'll notice that we've so far done this whole first column. Well, 3 things in the first column, and every single one of them has had 1 valence electron because the entire first column, they all have 1 valence electron, right? So if you look at this little section here on my P table, this tells you how to fill the shells. 2, 8, 1. 1. 2 in the inside shell, 1 in the outside shell. 2 in the inside shell, 8, and then 1. Potassium, 2, 8, 8, and 1, right? So it shows there's a 1 at the bottom, right? That always means there's 1 valence electron. Okay, so everything in the first column has 1 valence electron, all right? That's your cheat codes for now. Okay, let's then take that information and apply it to the periodic table. Okay. So everything in the first column should have 1 valence electron. Everything in the second column here has 2 valence electrons. Let's look at beryllium. Okay. So we're going to do beryllium really quick. Beryllium has an atomic number of 4, which means it should have 4 protons and 4 neutrons. Whoops. Sorry. That's for a different class. Okay. So let's do beryllium. Be. So beryllium has 4 protons in the nucleus, right? And we talked about how it should have 4 electrons, so we only need to have 4 seats. So C1, C2, and then C3, C4. How many valence electrons are there? There's 2. There's 1. There's 2. Okay. Let's go ahead and do magnesium. Magnesium has 12 valence electrons, so we'll say 12 protons and 12 electrons. That would be my son. He says hello. 12p plus. Okay. Pretend that connects for me, okay? Do me a favor. All right, sweet. Here we go. Now, if we've got 12 protons, we're going to put 12 electrons in, right? So 1, 2. Then we're going to fill again with the north, south, east, west rule. 1, 2, 3, 4. So that's 6, 7, 8, 9, 10. That's 8 there plus 2 there. And then we need what? 2 more? 11, 12. How many valence electrons are there? Hey, there's 2. Okay, so everything in the second column has 2 valence electrons. So there's a pattern here. The pattern, however, includes skipping everything in the pink here. Okay, so everything in this middle section, these are called the transition metals. The transition metals break these rules. They're weird, okay, because they're metals, they can have lots of different states. It's weird. So we're going to skip those for now. Okay, so when you see column 1, okay, 1 valence electron. Column 2, 2 valence electrons. Skip all the stuff in the middle. Then you get to column 13. It's convenient that it's a 13 because if you take away the 1 at the front, take away the 10 digit, look, it's a 3. How many valence electrons do you think there are? There's 3. Let's do boron just for practice, okay? So I'm going to bop over here. We're going to do boron. Sorry, this was magnesium. And then this here's boron. Okay. So boron's atomic number is 5. Yep, 5. Okay, so it should have 5 protons in the nucleus, which also means it should have 5 electrons around the outside if it's going to be neutral, which in this case, it's going to be neutral. Okay, so we sit 1 here. We sit 1 here. That's 1, 2, 3, 4, 5. And I went west. You could have gone east first. It doesn't make any difference. But what the key is here is, look, there's 3 electrons around the outside, which means it has 3 valence electrons. All right. So boron has 3 valence electrons, friends. That's the trick. That's what you need to know. Oh, goodness. We need another page, and I appear not to have one. Let me pause for a second. Okay, got a new page. All right. So we did boron. So we know that there's 1 valence electron, 2 valence electrons. Skip over to column 13. There's 3 valence electrons. So carbon should have 4 because everything in its column should have 4, right? Let's take a look. Carbon has 6 protons, right? So if we have 6 protons, we should have 6 electrons, right? So take a look. Carbon has 6 protons. Give it 1 ring. Give it 2 rings. And here we go. 1, 2, 3, 4, 5, 6. So you'll notice I went north, south, west, east, north, south, east, west. Doesn't make any difference, right? So you'll see there's 1, 2, 3, 4 electrons around the outside. Now, as you go down the columns, right? So if we were to do this for silicon, it would look the same on the outside. There'd just be an extra shell, right? So silicon, it doesn't look that much different from carbon. We would just fill this entire shell to 8, and then we would make a third shell around the outside, and we'd have 4 electrons in it. Okay, I hope you're starting to pick up this pattern. It's quite patterny. Okay, so next one is nitrogen. Nitrogen's number 7. Let's take a look. Okay, nitrogen number 7. So if it's number 7, that means it has 7 protons. I'm sorry, I'm making these huge now. All right, let's do this. 1, 2, 3, 4, 5, 6. Okay, we did our north, south, east, west. Now what do we do? Well, we're going to add another electron, right? 7. So how many valence electrons do we have? 1, 2, 3, 4, 5. And what column is this in? Column 15, baby. Okay, so do you see this pattern picking up? So you'll notice that oxygen then would have 6 valence electrons. All of its whole column does. 7 valence electrons, right? So let's just really quickly do those. All right. I'm just going to throw oxygen and fluorine up here real quick. So oxygen is number 8. So it should have 8 protons, and I'm writing P plus for protons. There we go. 1 ring, 2 rings. I'm going to erase that for you. Okay. This is oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then let's do fluorine. Fluorine's number 9. Swoop. Okay, there we go. And then we'll do one. Wow. See it? There. Nothing bad happened. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So how many valence electrons are there here? We should have 7. Let's look. Sorry, oxygen has 6, and then fluorine has 7. So we should have 6 valence, and then we should have 7 valence, right? Okay. So that's pretty much all of the tricks, right? So the only thing that you need to know now is okay, what happens with this last column? So the last column, column 18, helium and the family underneath, those are the noble gases. Noble gases have a full shell. So notice that helium is number 2. Let's take a look. Helium has 2 protons. And if helium is going to be neutral, helium's going to have 2 electrons. Boom. Full shell, right? Let's do the next one. The next one is neon. Neon's number 10. Neon. Neon's going to have 10 P plus. I should have put a P here. My apologies. There's 2. There's another shell. There's 8. Okay, that's 10. So we'll put 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2 is 10. Full shell, right? Now, helium is different because helium only has 2 protons, so it only has 1 energy shell, right? But everything else is going to have a larger, fuller energy shell, right? So neon's going to have 8, argon's going to have 8, and then things get a little weird, but they'll end up having 8. It doesn't really matter. It's tricky. Okay, so we're not going to worry about really what happens, except for you just need to know these all have a full shell of 8. Okay, they're all happy. So that's going to become important down the road. Okay. Let's talk about the cheat codes really quick. All right. So here's the cheat codes. Instead of drawing the Bohr model for all of these, you can just draw the valence electrons. Okay. We're going to draw a Lewis dot structure. So here's how you draw a Lewis structure. And I'm going to show it to you for a structure. Sorry, I'm getting distracted because you can probably hear my son. He's making noise. Very sorry. All right. Here we go. Hydrogen. How many valence electrons does hydrogen have? It has 1. Bop. That's for the entire column. Okay. Beryllium is next. How many valence electrons does beryllium have? Because it's in the second. It has 2. How do we fill it? North, south. 1, 2. Bop, bop. Then we skip this whole section, right? We're going to go to boron. Boron is 3 valence electrons, right? So 1, 2, 3, north, south, west. Again, you could have done east. It doesn't make any difference. Okay. Carbon. Carbon has 4 valence electrons, right? So carbon. And this is true for the entire column, right? Everything in carbon's column is going to have 4. Okay, I need to pause 1 second. Okay, I think he's calm. All right, 1, 2, 3, 4. We switch over here. Nitrogen. Nitrogen's number 7. Nitrogen has 5 valence electrons. Nitrogen. 1, 2, 3, 4, 5. There you have it, right? So I'll talk about that in a second. Okay, so we went north, south, east, west, right? And then we just pair them up. So what we're going to end up doing here as we pair them up is we're going to pair around clockwise. So next one up is going to be oxygen. Okay. So let's take our wrong color. Let's take oxygen and then we'll put our dots in. There's 1, there's 2, there's 3, there's 4, there's 5, there's 6. Cool. Pair, pair. And then these are blank, right? So then what do you do next? You'll have fluorine. Then you do one of these and you do one of those. Okay, north, south, east, west, north again, east again, south again, right? Pair, pair, pair. Shout out to all the pair. Okay, there we go, right? So there's one space available here, right? For fluorine. Fluorine wants 1 more electron to be a full happiness, and we'll talk about that next time. So let's then do neon, just for funsies. Okay, so if you were to do the dot structure for neon, it would be like this, except for it's in E. There we go. And neon's very happy. North, south, west, east, or east, west, doesn't matter. Pair, 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 pair. There we go. Full complement, all 8 valence electrons. Okay, so that's how you do Lewis structures or electron dot diagrams. I literally don't care if you use the word Lewis, it doesn't matter to me. If you can make this, then you know how many valence electrons there are. So we are going to practice this today, and that's a wrap. All right, thanks for watching.